Everyone. It is the second part of the video of the aromatic acid. In the continuation with the last part of the content, we can able to know that the carboxylic acid is meta-directing because the positive charge basically develops of the para and ortho position. That's why the electrophilic substitution cannot be possible in these two position. Hence, the electrophilic substitution is mostly done in the meta position. Today we will concentrate with why the carboxylic acid is considered to be as a deactivating. Because the benzoic acid undergoes electrophilic substitution is more slowly than the benzene. Because the carboxyl group withdraws electron from the ring by resonance. Here the resonance comes into plus R effect comes into factor, and it creates and withdraws the negative charge. Hence it decreases the electron density of the ring and makes it less attractive to an incoming electrophile. Hence the electrophilic substitution is slow. It requires vigorous reagent and conditions to carry on the reaction. Now we will focus a few reactions which we basically undergoes over the aromatic benzoic acids, which are as follows: the salt formation, the ester formation, acyl halide formation, reduction to benzyl alcohol, decarboxylation, or electrophilic substitution. The first thing which we'll consider is the salt formation. If we react the benzoic acid with sodium hydroxide, then the compound we get is a sodium benzoate. Is basically we can see that the change is overdoing over the acid part, not over the benzene part. The substitution is not here takes place, is basically a replacement of COAs to COONA. Followed by the ester formation. Here we can see the benzoic acid, if we treat with ethyl alcohol and sulfuric acid, then ethyl benzoate is being formed. Treating with ethyl alcohol and sulfuric acid, the ethyl benzoate is basically forming. Followed by the acyl halide formation. We have to take the PCl5 as a reagent. We treat with benzoic acid. The benzyl chloride, which is a very important part for the important compound for preparation of many things, which I have seen in our practical lab, and basically it is undergoing a own reduction from PCl5 to PCl3, and a corresponding HCl is being liberated to the formation of the benzyl chloride. Followed by, we have taken with the reduction to benzyl alcohol, we have to take lithium aluminum hydrogen LiAlH4, which we treat with benzoic acid. Then a benzyl alcohol, that is CH2OH, has been forming. Now we will take the decarboxylation reaction. We are treating with the benzoic with calcium oxide and sodium hydroxide, and a corresponding reduction has been done, and a benzene is being formed, plus calcium carbonate is also being forming along with it. Followed by the electrophilic substitution, which is very difficult in case of the benzoic acid, which have been discussed earlier, that a vigorous condition and a strong reagent has been required for carrying on the reaction, because due to the shipment of the electron density of the electron cloud over the benzene, as due to the resonance effect, it withdraws the electron density from the benzene, which makes it very less susceptible to electrophilic substitution. Here we have taken with nitric acid and sulfuric acid a strong reagent and strong condition, where we can get a 3-nitrobenzoic acid or meta nitrobenzoic acid, which I have discussed earlier, that due to the formation of positive charge over the para position and ortho position, it cannot be able to do a electrophilic substitution. Only the meta position is being susceptible for carrying on the reaction. That is all about the reactions. It is basically used for the germicide, urinary tract infection, and also being used as a fruit preservative. That's all for our aromatic acid part. Thank you.